One of the exercises that I'm going to ask you to give to try has a little bit of different notation in it. And so I'm going to use this video to talk a little bit about some alternative notation. Let me start with a generic matrix. We're going to have an M by N matrix. So this is M rows, and this is column 1. And I'll go all the way over to N columns. This is row 1, column N. Go down to row M, column N. And the ellipses that you see in here just indicate the missing entries. There actually should be N entries in this row and M columns with N entries, but I don't know what M and N are. They could be 2 and 3, or they could be 5 and 7, or they could be 463 and 923. So I don't know, but I'm just going to use those variables to, those constant variables to indicate that there are M rows and N columns. And then I have a column matrix here made up of my variables, x1 through xn. It has to be n because otherwise I can't do this matrix multiplication. This is an M by N matrix, and this is an N by 1 matrix. These numbers have to match. And then because they do, I can do the multiplication you see here, and the result will be an M by 1 matrix. So I'm going to have entries, M entries in this constant column matrix. So this is the notation that we've been using to talk about our matrix equations. And I said in an earlier video that we can also write AX equals B. And if I write that a little more in a more condensed form, you see this. And I said that usually in print, that X is bold to indicate that it's not just a variable X, but a matrix of X's, right? Another way you sometimes see this is as a capital X. But a third way that you sometimes see it is the X has a kind of half arrow over it, and the B also maybe has a little half arrow over it. And what that means is that the X that you see here is representing a very specific kind of matrix, a column matrix. And in future videos and future lectures, we're going to see that another word for that is a vector. If you've taken multivariable calculus or vector calculus, you'll understand what I mean by a vector. If you haven't, then don't panic. Mostly, I just want you to see that this notation here really means the same thing as the notation you see here. And what these mean is just what you see up here. So we'll get to what a vector is and how it's related to a matrix and how to work with them. We'll get to that. But for now, I just want you to be able to do that one exercise I have in mind for you at the end of this textbook section. The other thing you'll see in that exercise is notation that looks like this. X, they use a whole arrow rather than a half arrow. That's perfectly legitimate. A funny looking E, and then a funny looking R with a superscript of N. And what this means is that this thing we have down here, this X, which is really a column of X's, that's what this represents. That column of X's is an element of, is a member of the set of real numbers in dimension n. In other words, this is an n row matrix. It's an n by 1 matrix. That's really all this notation here means. The other thing that we've got in that problem setup is that B with an arrow over it, the funny E and the funny R, this time with an M, means exactly the same thing, but our B matrix, our B column matrix, which is a vector, is a member of the set or an element of the set, the real numbers in dimension n. And that just means that this is an M by 1 matrix. So that notation there is just telling you what the dimensions of the matrices are, and that the thing we're calling X with an arrow, the vector X, is just a column matrix. Okay, so just some unusual notation, or unusual for us right now, but this exercise is really the best one I found for my purposes right now. and I wanted you to know what that notation meant, so that you can proceed through the exercise without being confused just by notation we haven't talked about.